there are some main focuses in the new standard. Some of them are kind of at this point, like fall protection, they're kind of cut and dried. If you have questions about that, we'll entertain those, but we're not really going to give an opening statement about fall protection. Next one, FR, I'm going to ask Jim to talk just a moment about FR as far as an introduction.
Okay, basically, you can put 2 locking snap hooks in a D-ring. Sorry, I had to say it. All right, we'll explain it later if you need it. Come see me, I'll explain it. It's been a favorite topic the last few weeks. Here you go. On fall protection, you can sum it up this way. Every employer who has employees who work in an energized environment is required to do an analysis of that environment, identify the risks from arc hazard. Any part of your body that is exposed to a risk of arc hazard that will be above 2 calories per cubic centimeter sunburn level, you must protect that person, and that includes your face. The standard now requires, at 100% body protection, leather gloves protect your hands. It says work boots protect your feet. The 70E standard requires leather work boots. The OSHA standard just says good, so work boots, work shoes. But for the protection of your face, if your single phase exposure is less than 9 calories, you can protect your face with a pair of safety glasses, ANSI rated safety glasses, and a hard hat. If you have a multiple exposure, that key starts at 5. And here's the reason why. OSHA wanted to compel you to make sure that you restricted your exposure to single phase, so they put a harder criteria to meet in a multi-phase exposure in order to compel you to cover up, make a single phase. When it comes to secondary, meter bases, that's arc in a box. Face shields are going to be required. That's the only way you can protect your people pulling and setting meters. So those are the basics on arc protection under the new rule.
All right, thank you, Jim. All right, on host employer responsibilities, host client employer responsibilities, we're going to ask Ted to address that for a moment.
Okay, thank you, Mac. The host employer, contract employer responsibilities is really about the transfer of information, and that's the way the regulations are written. It's specific as far as what kind of information must be shared. But as we talk about, well, I'll touch base on a couple of those items. But the sharing of that information, one of the things you might think, well, how do you share it? Well, OSHA does not say you have to do formal letters. You just have to communicate the information. They've said phone calls and emails would work. I strongly would suggest that you have some kind of documentation that you have provided this information. That's your call there, and that's probably good business to do that. But that's where OSHA went as far as the regulations there. The host employer then in this standard must provide to the contractors the system characteristics, and we'll talk about them a little bit, the known conditions, the current conditions that are out there, any other system conditions that the contractor needs for their assessments, and that's something new there we'll be talking about, and anything else that the contractor needs related for safety purposes, et cetera. The system characteristics, again, OSHA is very specific on what is needed, and there's a list of them in the standard, and starting with the nominal voltage of the system, the transient voltages that are out there, any other hazards that exist, protective grounds, all those kind of items that are listed here, including specific information that's required for the contractor to do their assessment, okay? And their assessment then and OSHA gives you a matrix in their table. There's a table with a matrix lined up that says this is what the host needs to provide, and this is the assessment that the contractor has to do with these things. And there are actually a long list of these things. There are 10 items on this assessment. We don't need to go through them at this point, but know that they are there and know that that assessment needs to be done. Okay, now some of the information that may need to be provided there, if the host employer does not have that kind of information readily available, especially regarding the current characteristics of the system, because one of the things that they're asking the host to provide is, you know, are there grounds out there? You know, what are the conditions of the poles, et cetera? What are the environmental conditions that may exist out there? OSHA is not saying that the employer, the host needs to go out and do a survey of that information or send a whole team out there to inspect it in advance. They're just to provide the information they are aware of regarding the conditions out there. Then it's up to the contractor to go out there and assess that. But that is part of the information that needs to be provided. Now, from the other way around, if the contractor is out there, after they've done an assessment, the contractors obviously have a responsibility to communicate all that information to their employees. And that, you know, the tool there probably would be the tailboard, hazard assessment meetings, et cetera. That would be the method of getting everything that they've learned about the system to their employees. Makes sense, that's what they would be doing anyway. And that's another critical thing. Now, if the contractor is out there working on a condition, they find a hazardous condition that they were not aware of, they have 2 days to provide that information back to the host employer. Okay, so the host employer is made aware of hazardous conditions that are out there that they never reported on, and that's just their feedback back to the host employer. Okay, so that is that way, going the other way as far as communication. The last thing is the section they discuss is about coordinating work rules. Originally, there was a discussion about contractors had to work under the work rules of the utility, but that didn't get passed, needless to say, because that is way too complicated to deal with. So bottom line is, they say that the companies must coordinate their work rules. Now, what does that mean? An example of that might mean the various switching and tagging procedures that a utility would be using. That needs to be communicated to the contractor because we'd all be working under the same switching and tagging methods out there, how you identify flag grounds and that kind of stuff. That's the kind of information that needs to be shared. There may be some unique ways the utility does that needs to be shared, but as far as working 100% under the utility rules, that is not the case. Okay? Everybody needs to be working under OSHA standards there. And that's basically where we stand right now with that regulation. There's probably going to be a lot of discussion down the line about how this gets implemented, et cetera, and you may have some questions, but we'll deal with them as we go on here.
But one other thing, listen, you need to be still when you move, between the two of us, I'm
Yeah.
not sure that we don't
There's
exceed-
structural issues
we may
here.
not exceed the floor load here.
If we all of a sudden disappear, you'll understand what happened.
That's why I'm standing over here.
That may not be the best place to be.
All righty, thank you, Ted. We're going to ask Danny to talk a little bit about minimum approach distances.
Yeah, one of the favorite subjects and probably, I guess, most misunderstood and controversial now are the new tables with minimum approach distances out there. Of course, I guess the larger scheme of things, and OSHA split it at 72.5 kV. So, you know, from there down, medium voltage, they're up, higher voltages and EHVs. The minimum approach distances for the 72.5 kV and less down, and normal distribution working voltages that we all probably are working, either 12, 13, 19, 23, 25 kV, and even up to 34.5. Those distances really did not change a lot. They inched up a little bit. I think the 25 kV systems probably moved as much as anybody or any other section in there. Of course, if you remember in 2002, the National Electrical Safety Code suggested that on 25 kV it should be 31 inches. And now then, if you do the calculations, the electrical component and do the calculations in there and look at the alternative table, it comes up about the same thing at about 30.65 inches, I think, which rounded up to 31 inches. So it grew 3 inches, went from 28 to 31. And that's a big one. Now the 72.5 and above was where I guess the dramatic changes occurred. And now then we've gotten I don't know, I know we have quite a few transmission crews and companies represented in here. And when we get up to 345 and 500, it just goes a little bit crazy. And if I try to do the calculations the way I see them in the book and on the tables, I can't hardly climb past a phase on a 500 four-legged structure without violating minimum approach. I think the caveat in there that we didn't have before in R10 in the old 269 standard is we had that table set, but we really didn't consider that the other tables were there now. The altitude correction factors was there, and transient overvoltages was mentioned. But we never did really grasp them as companies. And now then we're forced to include those in there, and the employer now is responsible for actually determining what the minimum approach distances are on their systems. And I find that, and I have several customers out here that I deal with in the audience today, find that is very challenging right now. So, and we all know that everything now has been delayed till December 31st. And if anything, I don't know, in my estimation, if anything is beyond the 31st of December, it's going to probably be mad. It's just one of those things. It's just not there yet, and I think there's still a lot of judgment still left to be out. One thing I would like to add, of course, when they first published it back in April, they wanted to make sure we were looking at those tables. We immediately found a little error in the alternative table for the higher voltages, right, Jimbo?
Little.
Yeah, 3 feet 6 inches on 500. I said, well, that's going to work good, you know. And of course, this passed, but I think it's 3 meters. But anyway, or more. But the last week or so, I think I was actually doing a class and realized that even on the alternative table 6, and I don't know if you've noticed it or not, and they may have fixed it on the website now. So I was in touch with the Region 4 folks last week. They had a little error in there on 0 to 300 volts. And I don't know if anybody noticed it or not, but they said it's 0.50 of 1 kV. That's 500, isn't it? If I do my math right. It's supposed to have been 0.05. Nobody had caught it, and then I think somebody's in the audience out here that called me and said, Danny, look at this. And sure enough, Dan Sluter, I don't know where you're at, somewhere out here, but you know, just he called and said that, and we discovered another error, and I think they're probably correcting it now. So there'll be some other questions, I'm sure, in the open session, so I'll hush. I took way more than a minute, and that's all Mac gave me.
Okay, thank you, Danny and Jim. There's a few other little nuances out there, little items that we've picked up over time. I'm going to ask Jim to kind of cover a few of those before we go to open discussion.
Oh, you can use 2 snap hooks.
Oh, God. Give me a break.
Yeah. What were those new ones?
The grounding, secondary.
Oh, yes. There's been a lot, and we've answered some of these questions in the Q&A and also in the magazine. I encourage you to look. We spend a lot of time with a lot of expertise to help you guide yourself around these, around some of these questions. There isn't an issue with grounding secondary with your gloves if you're using an insulated ground. There is an issue with using a bare clamp onto a grounded, even if it's secondary, there's still a flash problem. And if you're using an insulated, like a 4 kV, some referred to as a fiber Mac, you know what I'm talking about? Okay, using those as a ground, you can install those grounds, and you can install them with your rubber gloves. So that's the big question that comes up most often. Anybody have an issue with that?
Verification of the absence of voltage
Absolutely.
prior to and while the voltage is there, and then watch it go away, I think is part of that new program too. In other words, you know, everybody's got fluke meters now. It's got a battery in it.
And it's not much different than the interpretation that OSHA issued a number of years ago when somebody asked, can you lift a jumper on a hotline clamp? Because of the requirements that you have to be able to break load with a rated device. And OSHA explained that the requirements for breaking load with a rated device was to protect the employee. In the administration of that interpretation, OSHA said, if your employee is out of the way and he can't be harmed by the resulting arc when you lift a hotline clamp, the employee is in no danger. It's not a violation of OSHA. Now, you may blow the pole top off and relay the feeder, but that's a different story. You're not hurting the employee. So it is not illegal to pick up or break a load on a hotline clamp for a jumper for a system, as long as the employee is not endangered by the resulting scenario. So blow the pole top off, don't hurt the lineman.
There you go.
How about anchor point?
Anchor points, we're talking about in fall protection. If you look very closely and in the interpretation, there is a lot of detail about the new requirements of the fall protection system. If you are using a fall protection device, I always try not to say one in particular. If you're using a fall protection device, and if you use that fall protection device appropriately, in other words, that device stays above your waist, you can restrict the fall at the waist. Remember, you cannot fall arrest at the waist. You can restrict the fall at the waist as long as your lineman does not climb past that device so that it's down at his knees and he's trying to throw it all the way back up. The resulting fall would exceed the distance for that fall limitation device. Now, if you are using your belt as a fall arrest device or a fall limitation device, there are requirements by OSHA as to the anchorage resistance where you're hooking up. The first one is that it be able to sustain the load imposed, which is the reason why I say, yeah, you can use a screwdriver, and he says, no, you can't use a screwdriver. Well, can't use a screwdriver. You can use a secondary fork. You can use a cross-arm brace. If the employer can show that it will sustain the load imposed upon it. Otherwise, if you can't show that, you're required to have a rated device that's just going to be 3,000 pounds or 5,000 pounds for a fall arrest device. Hopefully a climber's not going to be in a fall arrest. But you're also going to see a lot of utilities that are going to be changing over to full body harnesses so that they can distribute the loads of a fall and a fall arrest. There's nothing wrong with that. You're going to see a lot of utilities that are using 4-ring Ds. A lot of changes, nothing wrong with that. You want to know why you can? No, never mind.
Okay. Danny, you had a couple little ones?
Yeah, just a couple of short ones. These came up, and I actually called the Region 4 office and got a verbal. They won't put it in writing. But I don't know if anybody noticed it or not. In A2 qualifications, used to specifically say CPR and first aid. And what does it say now? First aid. And everybody comes and says, well, you mean I don't have to do CPR anymore? And I said, I don't think that's what they intended to do, but they went back to the NFPA 70E and some other documentations, in National Electrical Safety Code, and the American Heart Association now considers CPR training as part of first aid. So I said, well, you sure did throw a wrinkle in the sheet when you said that, because now people are asking a lot of questions. One of the things, too, that I personally discovered when I was doing a grounding class not too long ago is in paragraph Q. We don't usually read past, M and N.
There's a Q?
There's a Q, yeah, there is actually. It goes all the way to X, believe it or not. But anyway, in paragraph Q, in sentence paragraph, the big paragraph 2, the second paragraph, and it's Roman numeral 4. There was a time when we're installing conductors, if we're reconductoring, there was a reference to the maximum distance a set of grounds had to be placed. 2 miles, right? What does it say now? If the employer, has to consider it all hazardous, but if it can push 1 milliamp through a 500 ohm resistor, that's in the note up underneath that sentence, then it's considered hazardous. At 6 milliamps, you've got to protect. 1 milliamp is sensation. 6 is, now you're getting into, noticeable pain before you get the involuntary muscle contraction. And I asked the question, and I called Jim. I said, Jim, did you say no? I said, well, I didn't either, so don't feel bad. But, and nobody else did, because nobody had really had a chance to really get into it that far. But what does that really mean to us in the field? How do you insure? How does your company insure? And I guess that's the key words, is now the company has to demonstrate, or the company has to ensure that these hazards are identified and measures are taken to protect employees. Now, that means we got to do some more than what we've been doing, because obviously, grounds 2 miles apart was not enough. Somebody probably got hurt. And they said, oh, well, okay. Or somebody did some testing. And I think we all know, and I don't want to get into equipotential grounding, but you don't have 0 volts in between bracket grounds if you don't have another equipotential system to protect the employee.
Yeah, and we're also going to answer this again in in the December issue of the Q&A. Somebody asked a question. I had addressed this in the current issue about this because as Danny brought it to our attention. One of the reasons why OSHA removed the requirements on the placement of grounds was because they realized they were creating a procedure. And OSHA has a performance requirement, so they made the employer strictly responsible. And the other part, as Danny has already discussed, if you're putting grounds 2 miles apart, you might be creating a loop that's going to create a large current flow. So saying specifically no more than 2 miles apart could create issues. So OSHA's left that up to us. But, well, as we remind everybody, somebody said, are you saying that we shouldn't be putting grounds at breakovers and grounds or 2 miles apart? And I said, no, we didn't say that at all. You should stick to what you've been doing, but you should also use a consensus standard IEEE 516, and you will find that's exactly what the standard there says, makes those same recommendations, tells you where you should be putting your grounds and how to close up those risks to your employees. So do continue to ground.
Appendix C, which is fairly new and revised in the 269, deals with step and touch potentials. If you have not read over Appendix C in there, please do.
Thank you. All right, we're going to open this up to questions. Raise your hand if you've got a question here for the panel. We'll catch up to you with the mic and get the question on the mic as well as the answer. Who's got a question?
I just wondered if you guys give a brief overview or an explanation of what a transient overvoltage is.
Yes, there are a number of sources. Capacitor switching can create a transient overvoltage. Closing a transmission circuit on a cold transformer. Most engineers will tell you that in substations, if they have transformers off the line, they keep them humming and warm so there won't be a saturation surge if you were to close on one. Or if circuit relays, there is a sort of you might explain it as a factor that can happen that can trap and create these transients, and these transients can be anywhere from the phase voltage to 300 times the voltage on the circuit, and they can be in values in megahertz way above your hertz value, and on large thing can flash at the speed of light 90 times north across the length of a mile circuit. So the potential is great for these transients, and all designed to be able to handle the transients on the circuit. If you've got 20 insulators in a transmission string, the first 6 or 8 might be what's necessary for that phase to ground voltage, but the other ones are there to protect against these transients. The issue is that now we have more and more transients, and as these transients are more understood, one of the is that if you've got a guy on a string at an insulator or close to it, or if they have a basket or a bucket that's in that field around there, if that transient occurs on the circuit while you're there, it can disrupt the uniformity of the field around that conductor and create a flashover in that work environment that would endanger the lineman. So as they've looked at these mad distances, they're now calculating in these transients, and that's the reason why worst case at a transient factor of 3.0, if you were to multiply out, you'll see on that on the alternative scale, that 500 kV MAD between phases is 27 feet. It used to be 16 feet. And what they're calculating is worst case transient, which is the reason why now we do need to do calculations. But that's what transients are, and they are real. They can be dangerous. We haven't had much experience in the industry. I know of very few incidents where transients were decided to be the case of a flashover, but they can happen. Lab tests have shown that there's a potential for an issue with transients, and now that's why it's a big part of MAD. And in the 2017 issue of C2, the National Electrical Safety Code, their MAD distances are going to match the new MAD distances that are being employed by OSHA. Now, we do say this with all of these final rules. Several of them are being challenged by EEI on behalf of the industry. Some of these things may change over the coming months. I really don't think that the MAD distances are going to change very much, because what OSHA will tell you is if you calculate the distance is not that much greater than what we've worked at before, and they're manageable. But I went into my own shop and looked at, we do a lot of sticking on transmission, and I looked at the sticks that we have, and under those alternative tables, I'd have to replace almost all of our sticks for all of our bull gangs. You know, so we're gonna do calculating too, and if you calculate, it's much more manageable, and that's gonna be OSHA's defense, so.
It's two types of, from my understanding, there's two types of transient overvoltage. One of them's impulsive, which is more like a lightning strike, which we have no control over whatsoever. But the second, as Jim said, is what they call oscillatory. It's an oscilloscope, basically. And that happens from a breaker opening or closing in on that cold transformer, a capacitor bank coming online, offline. And if we happen to be on that line, when any of these things occur, then if you can, matter of fact, in my program I'm fixing to do at 1:30, I've got a picture of a nice calm lake. And that's the normal operation of a distribution, transmission. This can occur in anything. Of course, it's exaggerated in the transmission voltages. But all of a sudden, a tidal wave occurs. And that's the transient overvoltage. It's only there for nanoseconds. It's a wave that just will reflect back and forth. When it gets to a dead end, it expands, turns around, goes the other way, but it's doing it at 186,000 miles a second. So we can't control that. But you can imagine what happens to your MAD at that dead end or at that bundle if I'm sitting on it or got a bucket on it. What happens to that symmetrical field around that conductor? Now we've disrupted it, and we just don't want to be in that field when a transient overvoltage hits it, and the possibility of you becoming an electrode arcing to the bridge. That'd not be a good place.
And there are some controls in place. There are now 345 and 500 kV surge arresters that will help control transient. In your work site, there are some things you can do to help control them. You can block relaying, which is one of the sources. If you have an instantaneous relay, if you can block instantaneous relays, you can protect your crew. So there are protections that you can do so you don't have to worry about these overextended MADs. There are controls that you can put in place.
And the type breaker operations was the last thing I was going to mention, because there's a lot of talk about pre-strikes and restrikes in a breaker operation. You know, you get a vacuum breaker, SF6 breaker, and it's operating, it's only moving, it's only moving an inch or something, But the concern, and I think OSHA's concern from the conversation I had not too long ago with a person that's intimately involved in this, is the pre-strike, restrike. Now I'm closing the breaker, it's arcing to it before contacts close, or the breaker's opening, and before the contact's completely open, as it breaks load, it restrikes and restrikes and restrikes, which causes TOVs to go out and back. And there is, as we said, the type relays we've got now, and the type of breaker operations we got, the surge arresters, all of those things will help control those TOVs, but we don't really have our hands around it yet.
Then with the host employer rule, is it going to be up to the owning utility to explain to the contractor the total overvoltage on their system?
It would be, yes, that's one of the requirements. That's one of those listed as one of them.
The TOV rate, just like
Yep.
the ultimate fault capacity, in order so they can compute grounds.
Yep.
But they have to be able to provide them TOV so that they can compute their distances, or else tell them what the distances are.
All right, next question?
Yeah, Jim, going back to the transient voltages, has it been determined on this study if those circuits had any transpositions whatsoever, underground or overhead?
Yeah, didn't you ask me that yesterday? Somebody else asked me that yesterday. I have not seen in the literature that I've read on controlling TOVs, I haven't seen any recommendations that transposition of phases makes any difference. Theoretically, you might think that it does because of the increase in the field, and it might make a difference, but I haven't read any literature that recommends a transposition as control of TOV. And I see an engineer back there, I recognize, shaking his head. He didn't remember that either, right?
All right, next question?
And by the way, if you're not aware of it, transpositions are generally to control capacitance that's created on long line circuits, which is usually the reason for doing those transpositions, so.
Next?
Is it my understanding that if the utility does not do the protection potential calculations that it's up to the contractor to do those calculations?
Yes?
Did you say yes?
Yeah, yeah.
I didn't want to hear that.
Yeah, actually, I've already had, I'm a contractor, and I've already had some of our clients that are telling me, we are not going to give you TOBs. You're going to have to calculate worst case, and we're not going to tell you what our fault current is. And you're going to have to calculate worst case. And what they're telling us, in other words, that's what's known as bolted fault or unlimited bus, where you actually go out to the power transformer, you look at the KVA and the resistance, you determine what the unlimited bus is, and you work from there. So it's going to be an issue for a while. I think some utilities may be afraid. I shouldn't be out there putting things in your to think about to create more trouble for me. But there are some engineers that simply don't want to put their reputation on the line for fear that they're making a mistake, is what they're telling us. So I don't know how OSHA is going to deal with it when utilities stop doing that, and I don't know how we're going to deal with it when they tell me I got to be 27 feet away.
I was wondering if you could touch a little bit more about, and I think you mentioned, I was misunderstood, how the OSHA utility,
if you have a contract on the property, how they don't necessarily have to follow the same standards. I mean, I know they have to follow certain standards, but like you mentioned, lockout, tagout, and I get that. But as far as the safety rules,
They have to follow OSHA standards. Both of us, we all have to follow OSHA standards. Now, as we know, some companies, utilities go beyond OSHA standards in their rules, and contractors may go on. Some utilities require overshoes or sleeves in certain situations where some companies may not. The key is that things that are critical to safety that are communicated, that are shared. And obviously, switching procedures, switching and tagging procedures, everybody has to be on the same page there. But there may be some work methods that are different between the two. As long as they're meeting OSHA requirements, they're okay. Now, some companies may push that beyond, and that's up to the utility and the contractor. I'm just telling you what OSHA, allows. I know some companies say, you got to follow all of our regs. That's a relationship between those two companies at that point. But the key is that anything related to safety, that needs to be communicated and shared regarding the regulation and work practice. It's regulation, but it's really more work practice that we're talking about here.
Somewhere around page 1,000 in the preamble, if I remember correctly, after the third time I've read the thing, there was some conversations in there about that very thing, and I just remembered when we started about it. Some companies, well, obviously, performance standards is safety requirements. They are minimums. I think most companies probably require at least that much or more, but apparently there were some asking contractors to do less than what the standard required, which, then the contractor had the legitimate and legal complaint, say, can't do that. And so that was actually proposed in the preamble.
Yes. Yeah.
But it was not accepted by OSHA, because OSHA said, we ain't going there, which was a good thing. I mean, that was a fair and just thing to do.
Yeah, the backstory was that in the original notice of rulemaking, they proposed that the safety rules that the contractor had to follow them just as if they were OSHA rules. And this went on for a number of years, and a lot of people, but OSHA, the light suddenly went on and said, wait a minute, the employer is responsible for the employee's safety. The employer is responsible for interpreting the requirements of the standard and creating the safe work practices. And if we force that employer to follow somebody else's standard, how can we hold that employer responsible for the safety of his own personnel? And so they dropped that requirement. Now, the coordination of the rules that we're talking about, a real good example is one you mentioned, like switching and tagging. If you've got guys working on the same circuits in the same place, you want to coordinate your safety procedures so that one crew could not inadvertently affect another crew by what they're doing. You need to coordinate your work practices in order to ensure that you're not creating hazards for each other's groups. So.
They were worried about separate companies, separate contractors working on the same system and putting others at risk by the actions of one. But I think in theory, if we follow the standard as it's written, especially when it comes to switching and grounding, tagging and grounding, if theoretically, if we've got it right, if we've done what we're supposed to do, it can come hot and it shouldn't hurt us. It might put an OxyClean mark in your underwear, but it shouldn't kill anybody.
Well, let's give a round to our panel here. We've got some pretty knowledgeable experts here.